Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin Sime, founder and CEO of WebRTC.Ventures. Before we start today's episode, we need to share some very sad news. Our friend Dr. Alex passed away last week in a car accident in Thailand. He was founder of Cosmo Software and Millicast, and I've had the pleasure of working with him on a number of conferences and having him as a guest on WebRTC Live multiple times. The screenshot that I have up right now is a screen grab from his presentation at the IIT RTC conference that was virtual last year, and one of the many opportunities I've had to get to know him a little bit. And I picked this because you can clearly tell from the background it's late at night wherever he was when we did this conference appearance. And every time I spoke with him, I never knew where he was in the world. And since he frequently traveled between France, Thailand, the Philippines, Singapore for both business and family. No matter if it was 2 a.m. for him or not, though, he always had a quick wit, kind words, and a brilliant mind to share. It's a big loss in the WebRTC world, and I'll miss him. Before we had this terrible news, we did already have this episode of WebRTC Live scheduled with my guest, Ryan Jespersen, about the work that Millicast has been doing. So while this is a sad time, in honor of Dr. Alex, we're going to continue to celebrate the work he's done. And so I'm pleased to have Ryan here today, who will share with us more about Dr. Alex's vision and the Millicast team and where they are headed next. Thanks for joining us, Ryan.
Thanks, Arin, and thanks for those kind words. Yeah, it's an extremely difficult time for us at Cosmo and Millicast, and I think for those of you who have been in the WebRTC world for any amount of time, Dr. Alex is just a personality that is not soon forgotten. And let me share my screen, and I'll just share a couple of links that I think do him honor. He has a blog that I think was followed by a lot of people in the industry, and in that blog, we've posted kind of a message, mentioning that of his passing. And in here, I think the most important piece is we've included some snippets from Twitter. Those of you who maybe followed him on Twitter, he had a huge following, and he would always mix personal with professional, and he was quite a personality. And references to his family, he had 7 adopted children, Thailand and Philippines, and of course lived in Singapore. And he loves Southeast Asia, obviously was from France. And so we've taken a couple of those snippets and put them on here, so you can visit that blog. And then he was, like I mentioned, an enormous Twitter user. And so through the RTC Cosmo Twitter, we posted a message that I think a lot of people are responding to, and it's acting almost like a way to remember him. So feel free to post your comments on there. We're also talking internally about, he gave back a lot. Part of his culture was to contribute to open source projects. He wanted everything to be in the public domain. He was a big an educator and involved in with different universities and contributing to projects. And part of that is he encouraged a lot of young entrepreneurs and technologists in Southeast Asia to find their way into the professional world. And so we're considering creating a fund in his name that will allow people who want to contribute something to contribute to that fund that can go towards several individuals or a foundation that actually has that as their mantra. So we'll post that on Twitter when we do find an appropriate way for people to want to contribute and show their love. So with that in mind, I think like Arin mentioned, it was a very difficult time. We were a little torn when we sent out the news on Monday, whether we should proceed. But yeah, those that knew Alex know that he was a bit of a workaholic, going back from his time at Citrix to Temesis to Cosmo and now with Millicast. I don't know when that guy slept. And so we felt like there's no better way to kind of honor his memory and his vision than to continue on and do the amazing work that he was doing in the WebRTC space. So all of the information you're going to see today, I'm not going to take ownership of any of the vision in the message. This really was Dr. Alex's work and that of many of the Cosmo people that have been there since the beginning, including Sergio Garcia Murillo, who's our lead media engineer, Ludovic, who is a big contributor to IETF and W3C, along with Dr. Alex as well. So with that in mind, let's turn the meeting a little bit and get back a little bit into the depth of the WebRTC space. And what I wanted to kind of focus on today a little bit was how WebRTC is now being used to create a new generation of interactive real-time streaming solutions. And I think that the key to WebRTC, obviously, and why it's becoming so predominant is it's acted as a true replacement for a lot of broadcasters who are using RTMP end-to-end. And obviously, with the death of Flash, they've wanted to retain the sub-second latency for particular use cases that require that. And the reality is that, and here's just a quick message on Dr. Alex. I'll go ahead and proceed. So the amazing thing about what's happened in the last year is that it's obvious that human nature craves interaction, and that interaction leads to engagement. Everything from watch parties to virtual audiences. Roger Goodell, the commissioner of the NFL here in the United States, has made it very clear that he's trying to find new ways to engage with his audience, whether it's through Twitch, whether it's through watch parties or additional ways to try to create that engagement for a lot of people who can't make it to the stadium these days, or who maybe in the future can't anyway and want to interact through a virtual experience. And many people are trying to get this. I think all of us in the WebRTC space have heard of the proliferation of Clubhouse and other apps like it that are trying to create this two-way interaction where you can go from a passive to an active viewer. We've had huge amount of fundraising happening with Hopin, Around, Run the Worlds, and other WebRTC-based apps that have really validated the idea that there's this interaction that people want with our content. And this kind of interactivity is going to really touch every single market over the next few years. Everything from live sports to video-enabled e-commerce to live auctions, cloud gaming, remote production, betting and gambling, health and fitness, watch parties, education. Really, any, I think, vertical market is going to be touched by our technology. And a really good example of this is maybe about a year and a half ago, the idea of remote production really wasn't a thing. The idea that TV and film studios could collaborate on daily reviews and color grading for TV and film production with remote people. I think COVID has really propelled us in a direction where people are trying to use consumer grade equipment to do commercial grade workflows. And with people not being able to access their production broadcast equipment in studio, you need to find ways to collaborate. And WebRTC has really been that technology that allows us to wrap really high quality feeds inside of the WebRTC low latent protocol. And I think that's a very compelling piece as to the other potential apps that can come from our technology. So real quick, I'll go through these very quickly because I don't want to talk down to anyone on the call. I want to get more into the nitty-gritty of the tech. But the interactive live streaming piece is how do we achieve it? The reality to have two-way and dynamic upgrades, we need to have real time, nothing more than maybe 500 milliseconds of latency, high quality, even beyond web quality. RTMP right now is limited by H.264 and by certain limitations of that codec. With AV1 and a lot of other codecs, we can actually wrap them inside of WebRTC being agnostic and be able to take it to a new place doing HDR and true color video and surround sound and even high quality codecs like Dolby Vision. And then also web scale, the ability to scale. And I think this is one of the biggest things that's kept WebRTC from becoming a broadcast level carrier grade protocol is the fact that scaling it is not trivial. And I think those of you who have played around with it and tried to scale it to more than just a couple of hundred concurrent users know how difficult it can be. And then I think security is something that is going to make WebRTC stand out from other protocols by offering true end-to-end encryption. And I'll talk a little bit about how AV1 SVC and things like S-Frame are going to set the groundwork for creating true end-to-end encryption with WebRTC. So the first thing, and I think all of you know this, and I think WebRTC community really embraces standards. And the biggest thing is for us to all embrace internet, web, and media standards with the IETF, W3C, and AO media, because if we all follow that same standard, it's going to allow us to not go in the direction of proprietary implementations of WebSocket technology and WebRTC, but actually be able to all contribute to the same goal, which is proliferating WebRTC across devices. And I think if we do this, we'll enable native broadcast and playback on over 1 trillion internet-connected devices, and I think many of which currently haven't even been considered for WebRTC use cases. So everything from IoT devices to drones to, of course, game consoles and other devices. And I think this is where we get a little bit more into the technical requirements for what we need to do to make WebRTC available to all those devices. And what we have at Millicast and Cosmo is we have a very direct goal to actually bring client-side SDKs to all of these devices on top of the libWebRTC library. So everything from the JavaScript SDK that we are just finishing our new version of, that will have a broadcaster, a player, the ability to create iframes and example use cases for different JavaScript frameworks, the ability to create web native apps for people who want to go quick with the React Native app for iOS and Android. We also have on top of the x64 architecture, and I think a lot of you know Cosmo from this, and Dr. Alex is he forked to the OBS Studio to be able to include native WebRTC as a broadcasting protocol inside of that. And then what we've done as well, which a lot of you may not know of, is OBS. Obviously, we don't drive the roadmap for OBS, and we're limited by a lot of the codecs that they support. AV1 being one very good example, is we have created our own native desktop version that's available for Windows, Mac, and Linux that can allow us to actually encode AV1, connect a Blackmagic capture device, Decklink capture card, connect a nice high quality SDI feed, encode that at a very high level and start doing 10-bit and HDR and high quality things that aren't available in the browser yet. And that's really the idea of these client-side SDKs, is we can push the boundaries of what can be done inside of WebRTC that the browsers maybe will catch up to at a later time. And with Google Chrome just launching with M90 support for AV1, it's a very good example that real-time AV1 we already had working inside the SDKs, as I'm sure a lot of you did with other client-side SDKs. And then the other few ones we have here is trying to get not just the contribution side, but the playback side working on client-side SDKs. So we have the ability to with our iOS libraries, be able to play back on Apple TV and have native WebRTC support for that. And these SDKs, we have available in our GitHub projects that people can take and play with and build products on top of. And I think that's really part of Cosmos's mission. And of course, optionally using Millicast as a WebRTC scaling layer for the WebRTC piece. And then finally, we have on the Java architecture, the Android libraries. And funnily enough, with Android, we actually had this use case with Ricoh Theta, which creates a 360 camera. And they have the Theta V, and then they have the new Z1 that's about $1,000. That really is one of the best, prosumer, under $1,000 360 cameras that we're in the process of building an Android app for that will allow us to capture that natively in WebRTC and broadcast it directly into a WebRTC platform. So what this kind of sets the groundwork for is the use cases that I think really make WebRTC grow up and proliferate into all these different markets. We're working with a camera vendor known as BirdDog. BirdDog really created their name using the NDI protocol, which is something that NewTek developed for contributing broadcast quality things, usually over local or wide area networks. But BirdDog took it a step further, and they built these kind of internet-enabled IP cameras, PTZ cameras, and also other kind of encoders that allow you to do NDI contribution to their cloud. And we've done an integration with them where they have WebRTC in their cloud that can then connect to Millicast or other WebRTC platforms to then send that in real time across the world. So we have NBC and Amazon Prime that use this for the AVP beach volleyball circuit. And the funny thing there is Dr. Alex was actually a huge beach volleyball fan, so he was extremely stoked that it was used for the AVP Pro beach volleyball circuit. But we've also seen this year the NFL use it for monitoring in stadium for all of their 120 cameras they use for the production of the Super Bowl this year. So when you think about how you can control remote cameras and how you can monitor the feed, think of all the multi-viewers you would need to be able to control 120 different cameras. Well, what they did is they created a web app that would allow you to pull those feeds in WebRTC from these 120 cameras around the stadium, and the actual producer could go around on the stadium during the live match and see the live feed and tell his producers in booth to actually switch between those different live feeds. So people are building kind of multi-viewer things, not just in a local network or environment, but using the public cloud and over the public internet to create this kind of remote production workflow. And that's been the case too for NASA JPL. So the Jet Propulsion Laboratory has been in charge of the Mars Perseverance Rover. And when they were getting their live feeds from the Perseverance Rover, just over the last couple of weeks, within the last month, they've actually been monitoring and sending those streams to broadcasters like CNN and Associated Press and Reuters, where they can have, instead of sending it through satellite, which is very expensive, they can send raw, unedited feeds to these broadcasters through WebRTC. They can capture that, decode that, use that into their SDI workflow to use on air for their different use cases. So WebRTC is really being used as a way to create that kind of remote production workflow, which I think is quite interesting. And I mentioned OBS Studio. So with OBS, we have a lot of customers using this for kind of color grading for Adobe, Avid, even Pro Tools and 3D Studio, Maya type collaboration tools. And they're contributing that you can actually capture the NDI source across your local network, or you can just do a screen capture or actually capture it directly off a capture card that you have connected to your device. And people are doing this workflow and then enabling the playback of WebRTC across their different variety of apps, depending on what they want to get to. So the interesting thing about this is that we have some very high-end studios using this. Everything from NBC to CBS to NFL is using this for daily show production. We have Pacific Post Productions, PAC Post, that's one of the most recognized names in the broadcast and TV industry. And these kind of technologies, like I mentioned earlier, Evercast and SohoNet, Evercast specifically is a technology that was built by Dr. Alex and the Cosmo team and won an Emmy Award for that contribution to that space. So it's quite an interesting use case for how the WebRTC is being used. And the native app side of it, this is I think really where the future of WebRTC lies from a broadcast quality perspective.
Brian, can I interrupt you there for just a moment? I'm sorry. We have a question on the OBS,
absolutely,
on the previous slide. So Hugo asked if the forked OBS version that Cosmo and Millicast have provided will be using SRT as a transport stream.
So good question. What we've done is actually port WebRTC to it to replace any other kind of contribution protocol. So instead of using traditional RTMP, that's usually what OBS's bread and butter is, we've wanted to actually do WebRTC end-to-end with, so it replaces a need for SRT. So what SRT really tries to do is it tries to make TCP act like UDP or vice versa, where you can do a little bit, still have decent latency, but reduce the amount of packet loss that maybe you might experience with a UDP workflow in WebRTC. But the reality is that's still not going to get to the level of latency that most of our customers and I think WebRTC users want, which is sub-second. I think the other big piece, and if Dr. Alex was on this call, he would probably be fuming out of his ears right now. He wasn't a big fan of SRT because SRT at the end of the day is even though they've created this community that seems to be collaborative and it's not a standard recognized by the IETF or W3C or anybody else for that matter. It's really a standard that was pushed by Haivision and then my previous employer, Wowza, as well. They were the two co-founders of SRT. So he wanted to do everything based on IETF and W3 standards. So that's a long kind of winded answer of saying that no, SRT is not in our plans. We have had requests from other people when you talk about hardware encoders and contributions, but I'm going to talk about that in just a second because Dr. Alex, like with most things relating to WebRTC, had an answer for that as well. And the reality, I think, with his vision, when I finish kind of pitching the vision, you'll kind of understand why he wants WebRTC to be end-to-end all the way from encoder to playback is because of these other things that I'm going to discuss in the presentation today.
All right. Thanks for the question, and thank you, Ryan.
Yeah, thank you. So when it comes to Millicast Studio, the reason that Dr. Alex and his team decided to build their own custom SDK is because of the fact that OBS, we don't control the roadmap. We wanted to include AV1 encoding, real-time encoding inside of it. And we wanted to set the groundwork for an SDK that other hardware encoder vendors could take and build into their products. And that kind of libWebRTC architecture diagram is kind of what I was explaining. So we've done that. We have like an alpha version of this product that allows you to run that. And the GitHub repository is down here, and I'll post that on the chat here after the presentation. But you can download those pre-compiled versions for Windows, Mac, and Linux. And we've also created ones that the broadcaster can be used for Android and iOS as well. Obviously not for real-time AV1 right now, but you can do VP8, VP9, H.264 workflows for encoding with mobile devices as well. And we also have, with Millicast Studio, we have a Millicast player as well. And the cool thing about the implementation we have, and there's a video that we have on our YouTube channel that will show it, is we also can track a lot of client-side analytics, both at the broadcast layer and at the player layer, that currently is a big, I think, stopgap with a lot of people implementing WebRTC for broadcast workflows. With SRT, with Zixi, with even RTMP, they're very more mature technologies that have a lot of adoption and tools built around it for people to look at the broadcast quality of both the client side and the broadcast side. Client side, the receiver side and the sender side. And what Millicast Studio started was this ability to be able to monitor that in real time, have your source stream that's encoded on your local device, send it through your WebRTC platform, in our case, our Millicast platform, back to you, and you can use it as a real-time monitor to see what that feed is coming out. And then we could actually track the analytics of both the video and the audio to see if there are any frame drops, if there's buffering issues, all these different things that you could track at a kind of more granular level, the analytics of the broadcast. So I think that's a very interesting piece of WebRTC maturity and where it's going, that people are trying to build those kind of broadcast level tools around it. And a lot of what we're trying to do here is, like I mentioned previously, is really add things like true color, like 444 color, 10-bit and 12-bit workflows, HDR, Dolby Vision, custom codecs, right, for really high-end workflows. And I think this is a big differentiator to RTMP, and I think even to SRT. Don't quote me on that, but WebRTC is completely agnostic. It doesn't care what you wrap inside of it. And I think that's a really compelling argument to WebRTC, especially for these kind of use cases. If you're doing an encode-decode model, and you're working with a hardware encoder vendor that wants to do a solution for a high-end broadcast, they could have a contract with Dolby Vision and include that encode decode. And yes, it won't work in browser for browser decode, but it will work for that kind of broadcast contribution workflow, which is a very, very, very popular, I would say probably 40% of Millicast business right now is really in that broadcast space with really high-end tier 1 broadcasters. The same is true of surround sound. And then the piece I think that's really compelling that I'll mention later is the security piece. By not having to touch the media transport layer from encode to decode, especially with AV1 SVC, we can now add true end-to-end encryption. And I think the industry in general is kind of selling people a poor bill of goods, or however that's said, where they say they do DRM, but really what DRM is, you send RTMP in, you have to decode it, unencrypt it, then you have to add the DRM and encryption layer and send it, and the player is responsible for having the intelligence to decrypt for playback. But you're not keeping a true end-to-end encryption workflow. So when you think about WebRTC being used for government use cases, military use cases, the adult industry, all the liability that comes with having to control and encode during the media pipeline, if you host servers that have any kind of sensitive content, it creates a liability that a lot of people don't want to get into. And by having true end-to-end encryption, it really flips that on its head and really allows the WebRTC providers to not have that level of liability for any content going across their network. That was really one of the core pieces of Dr. Alex's vision, and AV1 SVC really enables that, and I'll explain that here in a bit. And as far as device reach, we need, of course, to get to all the devices where people are consuming content. One of the big reasons we developed an Apple TV OS device is because people wanted to use a 4K HDR output, and we wanted to be able to use a nice 4K TV for people to do daily reviews and film reviews, right? So that was one of the big pieces of why we ported it to the Apple OS. And then the resiliency piece, the AV1 SVC. Yes, people focus on the quality side of it and the bandwidth optimization, but the resiliency that AV1 adds, I think, is huge. The fact that we can do higher quality content to 2G, 3G networks, which much of the world is still trying to consume content through mobile towers that are using old technology. AV1 optimizes that across those networks by allowing us to send a 480p stream at a much lower quality. So it's not just trying to get into the 4K, 8K space. It's also about creating resiliency for poor networks. And like I mentioned, sender and receiver analytics as well. So I've talked a little bit about this, so I'll go through this quickly. I think really quick, I want to show you guys just a very quick demo here of OBS at work. And what I'll do, because I have videos for this, I want to be conscious of time. I know we're already running pretty close to the end of it. I have videos showing all these different workflows, and you guys can go consume those at your own leisure. Let me finish talking about the slides and Dr. Alex's vision, and then we can kind of reference any videos or workflows that you guys want to see after that. But really, the 360, we're working with Ricoh, and our team's working on an Android SDK build app for Ricoh that would allow you to capture the camera. The Theta device will actually stitch the two fisheye lenses into that 2D 4K layer, send that into Millicast. Then you would actually stream it using the app on your Android device or iOS device. That would be streamed. Currently, you can only stream that over RTMP, and that's true of things like the DJI Drone. It's true of other 360 camera vendors. And what we want to do is actually do that natively in WebRTC, so it brings that latency even further down. And think about what a true 360 workflow, like I was at Wowza when we were pushing 360 and working with all these 360 camera vendors. And I'll be honest with you, there wasn't a lot of revenue opportunity from that, because the reality, it was just kind of second screen experiences. It was just kind of cool to have, but not necessary. If we could truly do a 360 feed in real time, in sub 500 millisecond end to end, now we start talking about real use cases for telemedicine and for virtual tours. And there's a lot of, I think, really compelling use cases where WebRTC becomes a differentiating technology to make 360 actually come of age. And that's one of the things we're working on. I think it's an interesting use case for us to play with. And one of our internal developers, Robert, built a 360 player that is a very simple player. And we have that on our GitHub as well, where you can go and take that and be able to interpolate the stream coming off of Millicast, which is 2D, and wrap that inside the browser to kind of simulate that 3D experience with the controls for that, all inside of WebRTC, native in browser and in device. And this is true of the DJI MAVIC and other drones, is if we can also port apps to Android and iOS to grab those streams from your local device and stream them through the cloud, you can start using drones for, like a lot of people are already, for doing industrial reviews of dams or oil rigs, or for live concerts or live surfing competitions. All these things where drones are currently being used, but a lot of the technology that's having to be built onto them is quite cumbersome, with maybe using a Teradek cube or video and trying to do that through RTMP. You lose the low latency piece, and you lose kind of the benefits of WebRTC that it would bring to this. The ability to control drones remotely over the cloud would be available if you had a real-time feed coming through WebRTC. So I think this is kind of an interesting thing. I think you'll see a lot of people porting WebRTC to these kind of devices, including GoPros, right? You can do a GoPro stream using a local app as well, but doing that over WebRTC creates a lot of compelling use cases for those kind of run and gun prosumer cameras. And I think you've already seen some use cases with Unity and Unreal and gaming engines, and of course Stadia is very predominant in the WebRTC space. So everything from gaming to actually educational and medicinal use cases where people want to do telemedicine and learning. WebRTC is already available in the Unity, but building that and scaling that and creating also two-way interactions is something that people haven't really built yet inside those gaming engines. So it'd be interesting to see what comes of that. So with that, let me just kind of get into a little bit of the nitty-gritty of the tech side of it and part of Dr. Alex's vision. So, I think we can all agree that WebRTC has a very bright future, but for that bright future to kind of realize and come of age, we need to get as many people contributing into the WebRTC ecosystem as possible. And what WIP is the ability to do that. And I don't know how many of you have heard of this this initiative that Sergio Murillo, who's our lead media engineer and the author of the Meduse media server, and Dr. Alex kind of co-authored this draft with the IETF, where you can, so I think there's a standard when it comes to the WebRTC implementation. What's not standardized is the signaling layer of how you communicate and create a handshake between devices and WebRTC platforms. So what WIP was trying to do was create a standard through the IETF of how you create that signaling layer between devices. So what this will allow hardware and software encoders to do is create this native way that we all communicate over WebRTC from a signaling layer. So if Teradek or Videon or Aja or any other hardware or software encoder like Telestream Wirecast or vMix or all these guys wanted to actually add WebRTC to it, all they have to do is have the WebRTC protocol piece, but then add the WIP piece to actually do the contribution layer. So this is something that's currently being reviewed by the IETF, and I think it's called WISH under there, because there was a conflict with the WIP name. But I'm sure Sergio is going to talk a lot about this in a couple of weeks when he presents on his session. But I think this is the momentum that I'm trying to push into the hardware encoder market. And if you guys have influence with any hardware encoder vendors, take a look at this spec and try to get all these devices to do that, because I think a lot of our customers are trying to still do an SDI capture or HDMI capture and use WebRTC's benefits with those hardware kind of encoder devices. And not just encoder, but also decoder. We have so many broadcast studios that are also trying to decode and output to SDI so they can use that as a real-time feed inside of their mixing for live production. And the final piece, and I'll try to go through this quickly, I know I'm over time. The final piece I'll talk about is a little bit of the interactivity layer. So I've talked a lot about WebRTC and use cases and all that, and I think a lot of us knew maybe about much of that. But I think what's really interesting is where WebRTC is going next. And no other technology really has what's needed to add the piece of interactivity that or the building blocks that I mentioned earlier when it comes to latency, quality, scale, and security. So one of the things that we've seen is, watch parties is nothing new. We've had quite a few companies come up in the last couple of years that have watch party type use cases. And what they've done is they've had like an HLS output for the Champions League or the Super Bowl, and they built a WebRTC watch party type thing in a SDK that you can build into your playback app. So that's kind of the use case for watch parties. But the layer of trying to create the interactivity between the content and the real-time collaboration piece of the attendees, that kind of two-way layering is something that still hasn't really happened in the video and audio space. So what we want to be able to do, and what we're working on ourselves, is the ability to have this linear stream, but also create watch parties all through an API that people can go and build products on top of. And similarly, the ability to create a stream party. And I think this piece is the most compelling piece. Is right now, people are trying to use Zoom and Teams and other real-time collaboration tools, WebEx and so on, for broadcast quality workflows, but yet they can't control the quality of the stream inside of those tools. It kind of goes into this black box. Those workflows control those encoding workflows, and you don't have control over the quality. In addition to the fact you can't build a product on top of Zoom or Teams or so on and create a white label product to go to market. So I think we need a WebRTC piece, and the Clubhouse app that was built on Agora is a very good example of this. They have the ability to have co-hosts, granted with audio only. They have a media server that creates a linear stream or a single stream out of that, so pretty much an encode. Send that into a scaling layer that you can now scale that to hundreds, thousands, or millions of concurrent viewers. But the piece that's missing right now is if one of these passive viewers wants to become an active participant in that meeting. That's the piece that we're working on, and we want to enable through APIs so people can build a Clubhouse, but for video and audio as well. And of course, scaling that for video is much more complex, as you guys well know, than scaling that for audio. And this is kind of what the high-level architecture would look like. Is right now, Millicast is pretty much this layer where you have WebRTC in, and you can scale that to millions of concurrent viewers at low latency and so on. But what we want to build is this idea of this stream party where we can encode multiple streams and control the single output of that into that layer. And then similarly on the back end, have a or on the consumer side, the playback side, have a watch party where people can contribute and then switch in dynamically between there. And then all these other things that I think a lot of people are already doing, like restreaming to, social media through RTMP and HLS and all that stuff. And one of the customers that we have that's actually already built this kind of Millicast 2.0 workflow is a company called StreamClick. And I encourage you to actually go to, so this is built by Megaphone TV, which I think some of you may know in the industry. They've done a lot of stuff like Bravo TV and a lot of broadcast quality, virtual audience engagement type use cases, where you can add real-time graphics all inside of WebRTC native to the browser. So what they've done is taken it a step further and built a tool that you can do webinars and all kinds of use cases for broadcast quality workflows that adds the interactivity layer. So I encourage you to visit StreamClick by Megaphone TV and try that out to see what kind of some of those interactivity pieces are looking like. And with that, let me just sign off by saying that in 2 weeks' time, Sergio is going to take the place of Dr. Alex, and he's exactly the right person to be presenting that session. He's the one who's done the work on implementing real-time AV1 SVC encoding with our Millicast platform inside of Chrome Canary that coincidentally I think just launched today or yesterday publicly. So he's got AV1 SVC working in real time in browser, and you can see here he's got that working at 30 frames per second at a pretty, I think it's at like a 720p or a pretty high resolution already. So it's quite a compelling thing, because with AV1 SVC, the benefit of this is that there's no need to re-encode. Like I said, that media transport layer stays true from encode to decode, because those layers inside of the SVC or inside of the AV1 codec are already there. So you can get the benefits of ABR without having to re-encode. And that means that end-to-end encryption can be enabled. And he'll talk a little bit about that with secure frames. And there's another draft of the secure frames project. And I think that one's going to take a little bit longer maybe than WIP, but when true end-to-end encryption makes its way into WebRTC, I think that's a really, really game changer for WebRTC proliferation across the industry for even a lot of workflows that currently don't embrace that technology. So sorry for going over. I know it's a lot of information, but that's a really high-end view of Dr. Alex's vision, and there's so many intricacies to all those pieces. But yeah, I think we'll open it up to questions now, and I'm sure there's a few.
Yeah, thank you, Ryan. That was all very interesting, and really appreciate it. We have another question related to AV1, and perhaps a good segue to you having mentioned Sergio's talk coming up in 2 weeks on WebRTC Live, but asking if we're going to reach AV1 real-time encoding on the browser in the near future. So is that what's in Canary now, or what's to come there?
So there's two things that launched in the new version of Chrome M90 that are key. One is AV1 encoding. The second is actually the RTP header. So both of those things put together is what allows for AV1 SVC and sets the groundwork as well for what can be done with end-to-end encryption in the future. So if you go to Dr. Alex's blog, and we're going to keep this up, I think, for many years to come, there is a blog post on real-time AV1 SVC, and I'll post this in the chat, unleashing the true power of WebRTC. And it gets a lot more technical on what is being done and what AV1 SVC will enable, and how Chrome's launch of M90 kind of ties into that. But to be honest, Sergio's presentation in a couple of weeks' time is the perfect setting for him to talk about this and why this is such a differentiator. And he's incredibly more technical than I am. So he's a great person to, I think, talk about that piece in more detail.
Excellent. Yeah, thanks for sharing that link to the blog post in the chat here. And when we post this session to YouTube and also on our blog at WebRTC.Ventures, we'll include those links as well. So, Ryan, you talked about client-side SDKs and having those across all platforms. Once you have that in place with Millicast, are there still technical benefit? I mean, then you have the option of basically going through browsers and native applications. And so what I'm wondering is, do you Are there still going to be technical benefits to going with a native application implementation at that point? How do you, if you have the choice on a given device, which platform or SDK to use, do you see differences between them, or is it more or less the same?
So Dr. Alex's vision here was he wanted to control the client-side SDKs and have that as an option to keep pushing the technology along. Things like AV1 SVC is a good example. We already had that working, and Sergio and Alex and our engineering team had that working for I think close to a year inside of the Millicast platform. So it's been there already. However, no browser enabled it yet. So, browsers, of course, they've got to do their due diligence, and they've got a roadmap that maybe extends out. And they also want to follow standards, which is why Alex and the Cosmo team are so entrenched and embedded in the IETF, W3C, and AO media spaces, because they want everything to be standard driven. But standard committees take a while, like secure frames and AV1 SVC, we could do that right now inside of the clients, but we want it to be in browser because every single internet connected device has those browsers. So that gets you to all those places. So the idea of the client-side SDK is that we can control that roadmap and push things along. The things that we're working on next are those things like quality, HDR, 10-bit, hopefully high-end codecs, even H.265. You can do an H.265 workflow, and obviously Apple devices already have H.265 enabled, so you can get to the Apple TV, you can get to iOS devices, but it does, and you can get to Safari natively on the Mac, but that limits you to getting to other devices that don't have H.265 decoding, which is many of the other browsers and devices. So, all those things, it just depends on what your workflow is and what your customer's workflow is if you're developing WebRTC solutions. But he always wanted to have a solution that was pushing the boundaries, and then he wanted another solution that was on par with the web browser. And I think that's what his work in the standard committee meetings was really driven by, is making sure that whatever technology he worked on would make it in to that. And I think in that, he was very visionary too. He had, I think almost 10 years of influence, right, with those standard committee meetings. And we continue to have through Ludovic and through Sergio, who are two of my colleagues. They continue to be involved in those communities.
Oh, that's great. Thank you. So definitely the, things like Millicast provides and having this true real-time video at scale allows for the watch party type of scenarios. And I like how you talked about the transition from passive to active participation for viewers. The fact that we can do that now at scale is a sign of WebRTC maturity, I think is a really interesting point and very transformational for a lot of use cases. Does it also mean that we can be truly omni-channel in a real-time sense? And sort of example that I'm thinking of there is, watching a live stream sporting event, right? And watching that on your device as you're the passenger, not the driver in a car. But then when you get home, being able to immediately switch to your TV to cast it up on Apple TV, things like that, and still not miss the experience. Can we be real time in that sort of omni-channel sense, excuse me, as well as in the watch party type of sense on a single channel?
Yeah, the casting is a good example. Right now, there's nothing limiting you from being able to cast WebRTC to Chromecast, as an example, or to share that to Apple TV. You could take an SDK, either ours or your own, and be able to build a native app for Android, let's say, on our Java framework, and then take that to market, have a WebRTC real-time latency playback, and then cast that to Chromecast. That's already a workflow that works. I think it's going to be a long time before the big events. I think that there's the economies of scale of HLS and Dash being HTTP protocols that the CDNs have embraced. And, I think it is still true that, things can still be 10, 20 seconds latent with those protocols, and most people still don't care. And because there's a race to zero as a commodity with HLS and Dash, the price is just so cheap compared to any kind of stateful servers, WebRTC being an example. The economies of scale of trying to do that doesn't quite compare. But it doesn't mean that CDNs aren't interested in WebRTC. Limelight obviously is launching RTS. There's been a lot of interest from other CDNs in the space. There is a huge need for things that are sub-second, right? And a huge market for that. And I think all of you know those different vertical markets. But yeah, the quicker and the faster we can all work together to get this onto different devices and start building apps around WebRTC, I think the more adoption and the faster the adoption is going to happen of using this technology and replacing a lot of workflows that really are kind of broken workflows that don't have interactivity elements. And there's a lot of stuff as well that needs to happen. We get the request all the time. Oh, do you do closed captions? Do you do, like multi-language support? Do you do, and those are all things you can wrap inside the data channel. And I think more and more people are going to start building features around WebRTC that make it act more like a broadcast quality protocol, especially for playback. But the thing for all the haters that are out there for WebRTC, I keep telling them, because there are a lot of haters that are like, well, it doesn't do this and it doesn't do that. Well, it doesn't do that because the maturity in the space and the use case, WebRTC was never designed for this use case to begin with. But all the benefits that WebRTC offers and the ability that it's natively available on every single internet connected device in the world, you can't say that for HLS. HLS only works natively on iOS devices. Everyone else needs a third-party player to be able to get HLS to work. Like, that alone tells you it's a proprietary workflow. It's kind of broken in that respect, and it's not embraced as a standard end-to-end native piece like WebRTC is. So I think more and more we're going to start seeing that kind of Venn diagram of the WebRTC space getting into the broadcast space, because it offers so much more.
Thank you, Ryan. All right, one more question from the audience here. Will AV1 take advantage of WebGPU for rendering?
That is a great question, I think, for Sergio. So I'm going to
and a good segue as our last question.
Yeah, and I believe the implementation he has working is purely CPU based. So we need to see exactly how you can do hardware acceleration. I know a lot of our roadmap this year around AV1 was around hardware acceleration across different chipsets and different OSs. So a lot of it is limited by, Dr. Alex was working a lot with Intel and with Xilinx and with Qualcomm and trying to convince them that they need to add, more support for AV1 real-time encode, right? I think that if we can fit, and I don't want to focus purely on AV1 because the use cases for WebRTC span way beyond that. Already the use cases with H.264 and with VP9 and VP8, you can cover most use cases with that. It's just more future looking of where it's going. I think the amazing thing about AV1 and what the Alliance for Open Media did very, very well is, first of all, the licensing model for AV1 is very clear, as opposed to H.265, which everyone's still fighting over. The second piece of that too is the fact that they focus on the decode side of it first. So almost every device that's out there right now, as of the last 3 or 4 years, has AV1 decode by default. And you see Netflix switch to their entire VOD library being AV1 encoded. YouTube, a lot of their library is AV1 encoded. Of course, those are all VOD workflows, not live workflows. But the minute we can solve the real-time AV1 piece and make it web-enabled, and also all other kind of hardware that we want to get in there, including all these decoders or encoders that we're talking about, the decode side is already solved. It already works, and it already is very, very optimized to devices for decode. So I think that's the next step, and I think by end of year you'll see. I think within, this is kind of a bold statement, but I think within 5 years you won't see a hardware encoder. I really don't. I think everything's going to be done in browser. Look how quick this is growing, and all you'll need is a way to kind of capture the SDI into a MacBook Pro or even a mobile device, and you'll encode in browser for all of this. And I think hardware encoder need to get on that bandwagon.
We'll go ahead and book you on WebRTC Live for 5 years from now to test out that bold prediction. But in all seriousness, Ryan, thank you very much for joining us today. A lot of very complimentary compliments in the chat here as well. This was a really interesting session. Thank you very much. I know you mentioned having some other videos, I think you said, around use cases that we didn't have time for. Anything you have like that, let me know, and we'll put that up on our blog as well when we have the recording on this and up on YouTube. Ryan, thank you so much for joining us. Once again, our condolences and best wishes to you and to everyone at Millicast and Cosmo, and of course, Dr. Alex's family as well. Really appreciate you joining us today.
Thank you so much, Arin. I mean, it really does mean a lot to us. It's been a very, very difficult time this last five days. Very difficult time, especially, I knew Alex for about a year, and Ludovic, who's known him for over 15 years. There's some of them who this has been a major loss of a friend. And I think you can see my energy. I'm a pretty energetic guy, but the passion that Dr. Alex had for WebRTC, he's sold me on it. And this is going to be how I spend the rest of my career, is focusing on this part of the stream media space. And I can imagine no better legacy than for all of us to kind of push WebRTC forward. So, yeah, and we'll be in touch as far as best ways to kind of remember him through the blog and through our Twitter. So I appreciate all the kind messages, everyone.
Yeah, thank you. Please do keep us posted of that. We'll certainly share it with our viewers as well. And we will, continue on the evolution of WebRTC. In 2 weeks from today, as Ryan has said, Sergio Maria from Cosmo will join us to talk about the evolution of WebRTC. Topics around there we're expecting will be around AV1 and the WebRTC media pipeline, WIP, as Ryan mentioned. So please do join us there, and we'll continue this conversation in 2 weeks and thereafter. So thanks again for joining us, Ryan. Thank you all for joining us today for WebRTC Live. We'll post this video to YouTube and our blog in the next week. To find out more about our upcoming episodes, follow us on Twitter at WebRTC.Ventures and join our email list at WebRTC.Ventures. Thanks, everyone, for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.